What's up, Math 6 students? It's time to find the surface area of prisms. Well, I like finding the area of every face and base on a prism. Add them together, that's the surface area. Remember the good old days when I'd annoy you with all of my bad ukulele songs? Well, I haven't forgotten. Maybe you have, but I haven't forgotten. And now I still get to annoy you. It's so beautiful. Chapter 8, Section 2, surface area of prisms. And I already wrote down the essential question because I've been having so much trouble writing it. So how do I find the area of all of the two-dimensional faces and bases on a prism? And you could like pause the video right now and write that in on your own notes if you've printed them out. But let's think about that essential question. For those of you who already have finished it, if you look at a prism, like this one's a rectangular prism because it has parallel and identical rectangles, which make it a rectangular prism, or a triangular prism, parallel and identical triangles. So this is a triangular prism. They're 3D. They have length, they have width, and they have height. So when we're talking about area, we're talking about square area. How many squares does it take to cover it? Well, we can't fill up a three-dimensional shape like this with squares. But what we can do is we can take this three-dimensional prism and we can unfold it. We can unfold it, and you can see this red part. I guess they wanted this to be the base, right? So this top has a bottom, which is parallel and identical. We can unfold it into a flat surface. And when we do, now we can figure out how many squares it takes to cover it. Because area is a two-dimensional measure. How many squares does it take to cover all of these rectangles that make up this rectangular prism? And when we do unfold it, it's called a net. So the net of a rectangular prism it's a prism with rectangular bases, and as you can see, there's actually a whole bunch of rectangles. How many? Well, there's 6 total, but I don't know if you can see this, but do you see this left side that's blue? Let's say that's here. Well, the opposite side is the exact same rectangle. That's this blue side, right? So these two rectangles are the same. How about the front? Do you see the green front? Well, isn't the back identical to the front? So the front and the back are identical. You can see them here. Here's the back and here's the front. And finally, the top and the bottom, they are also identical. So there's 6 total rectangles, but there's 3 pairs of identical rectangles. Remember, pairs are like shoes, 2 shoes. So here's 1 pair of the blues, 2 pairs the greens, 3 pairs the reds. The net of a triangular prism is a prism with triangular bases, right? They're parallel and identical. Do you see these 2 green triangles? So there's 2 triangles in a triangular prism, and then there are how many rectangles? The one blue side, that's this blue side here, blue, blue. The orange rectangle here and here, and then at the bottom we have the red rectangle. Now this base is pointing to the green triangle, so the red one's actually underneath, and then there's the red rectangle. And all 3 of these rectangles could be the same. 2 of them could be the same. All 3 of them could be the same. It depends on what the dimensions are. That means what the measurements are. So I'm going to stop this video here. That's part 1, and then we'll go on to the next video to do the first example.